Hi everyone. In this video, we're going to talk about two more rules for finding derivatives. So you can also think of these as differentiation formulas. So we're going to talk about what's called the product rule and the quotient rule. Now, so far you have learned the power rule, okay? So if you wanted to find the derivative of h of x, you would have to multiply before you apply the power rule, okay? So right now, with what you know, you would distribute the 3x squared. So that would give us 15x cubed plus 3x squared. And then we would be able to apply the power rule to find our derivative, okay? So h prime of x would equal 3 times 15, which is 45, times x squared, plus 2 times 3 is 6, times x to the first power. Okay? So this is using the power rule. Okay, I want to show you that there's a different way to go about finding that derivative. And that's using what's called the product rule. So the product rule is used whenever you're multiplying two functions. So let's say we have f of x times g of x. Okay? So anytime you're multiplying two functions, you can use the product rule. And it works like this. It's f of x times g prime of x plus g of x times f prime of x. Okay, so that's the product rule formula. Now, there's a little bit easier way to remember it.
Miss Miarka, if you're in the building, will you please call extension 1000? Thank you.
And let me add the derivative there. If you have a product of two functions, to find that derivative, this is your product rule. Here's a way that you can remember it in your head. It's the first function times the derivative of the second function plus the second function times the derivative of the first function. So a lot of times when I'm doing this, I'll say this in my head. First times derivative of the second plus second times derivative of the first. All right, so let's look at the same example but using the product rule. Okay, so let's look at this same example, but now let's find the derivative using the product rule so you can see what happens. Okay. Oh, let me close this. There we go. All right, so in this case, your first function is 3x squared, and the second function is the 5x plus 1. Okay, so h prime of x would equal the first function times the derivative of the second function. So you are still using the power rule to find these derivatives. The derivative of 5x plus 1 is 5, using the power rule. Okay? Plus the second function, 5x plus 1, times the derivative of the first function. And so that would be 6x using the power rule. Okay? And that's why I told you guys in class that you're going to become a pro at the power rule. It'll become second nature to you because you're going to use it so much. All right, so then we just need to simplify this. Let's start by multiplying 3x squared times 5. So that's 15x squared. And then over here, we will distribute that 6x. So we get 6x times 5x is 30x squared. And 6x times 1 is 6x. And then just combine your like terms. so we can combine here and get 45x squared plus 6x. So that is h prime of x. And so I just want to show you that we did come up with the same derivative, but just two different ways. Okay, so that's the product rule. Let's look at one more example. Okay, so here the first function is x to the negative 1 plus 2, and the second function is x to the 3/2 plus 1. So again, as you're writing this out, just say the rule in your head, okay? Y prime would equal the first function times the derivative of the second function. So x to the 3/2, using the power rule, that becomes 3/2 x to the 1/2 power, plus 0, because the derivative of 1 is 0. All right, so I didn't need that much space. Okay, plus the second function times the derivative of the first function. So again, using our power rule, we would get negative x to the negative 2 plus 0. All right, so then we just have to simplify. So we're going to distribute here. All right, so we get 3/2 x. Now we're adding our exponent. So we're adding negative 1 plus 1/2. So I would make that negative 1, negative 2 over 2 plus 1/2. Add your numerator, and we get negative 1/2. Okay, and then 3/2 x to the 1/2 times 2. There we're just multiplying 2 times 3/2, and that's like 2 over 1. So your 2's are going to cross reduce, and that'll just equal 3 times x to the 1/2 power. All right, and then let's distribute over here. So we have negative. This will be a negative because we have a negative times a positive. And then we're going to add our exponents. So we have 3/2 plus negative 2, which would be like negative 2 over 1. And then we need a common denominator. So we'll make this negative 4 over 2. And then add your numerators, and you'll get negative 1 over 2, or negative 1/2. Okay, so this will become minus x to the negative 1/2. And then distribute or multiply times the 1, so we'll just get minus x to the negative 2. All right, so then just combine your like terms. I'm going to get rid of some of this extra work. We can combine this term with this term. So 3/2 minus 1. And you guys remember, like 3/2 is 1 1/2. So 1 1/2 minus 1 is just a half. Okay. So that'll equal 1/2 x to the negative 1/2 plus 3x to the 1/2 minus x to the negative 2. Okay, so sometimes you'll see the answer written like that, and then sometimes you'll see it simplified, meaning get rid of the negative exponents and convert your fractional exponents to radicals. Okay. So I think we're just going to leave it like this for now, okay? Because we'll practice some of that simplifying in class, okay? I just want you to get the hang of the product rule in the video. Okay, now, the third rule is called the quotient rule. And so your quotient rule is used anytime you are dividing two functions. So if you have f of x over g of x. So to find that derivative, it equals g of x times the derivative of f of x, so f prime of x, minus f of x times the derivative of g of x, all over g of x squared. All right, now this rule is a little bit more difficult to remember, okay? There is a little shortcut, a little saying that you can say in your mind, kind of like we did the first times derivative of the second plus second times derivative of the first, or the product rule. And instead of using f of x, g of x, it works like this. You call f of x the high function and g of x the low function. Okay, just because, you know, high, low, numerator, denominator. All right, so to find that derivative, it works like this. It's low d high, so derivative of high, minus high d low, all over low squared. So it's kind of a saying that you can say in your head whenever you're finding your derivative. It's definitely helpful for me because you can say it very quickly. Low d high minus high d low all over low squared. And it really helps. Okay, so let's look at an example of a quotient rule. So let's say that f of x is equal to x squared plus 4 over x minus 2. Okay? So this is high, this is low. Okay, so to find our derivative, f prime of x, you start with low, because it's low d high minus high d low all over low squared. So low d high, so the derivative of x squared plus 4, which is 2x, minus high, which is x squared plus 4, times the derivative of low. Now, the derivative of x minus 2 is just 1. All over low squared. Okay? And then you mainly just have to simplify that numerator. So let's distribute our 2x. So we get 2x squared minus 4x. Now we're multiplying x squared plus 4 times 1, so that's just x squared plus 4. But you do have to distribute your negative, so it becomes minus x squared minus 4, all over x minus 2 squared. All right, and then combine your like terms. 2x squared minus 1x squared is 1x squared minus 4x minus 4, all over x minus 2 squared. You could also FOIL the x minus 2 squared. You might see that done in some of the answers. Most of the time, though, we consider simplified form factored form. So in some cases, if you can factor, you would want to do the factoring and then see if you can cancel any factors. But the x squared minus 4x minus 4 is not factorable because, you know, we can't find factors of negative 4 that add to negative 4. Okay, factors of 4 are 2 and 2. To add to negative 4, they'd have to both be negative, which means if you multiply them, you'll get a positive. So the numerator is not factorable. Okay. All right. So there is the derivative using the quotient rule. Okay, so we're going to practice this more in class tomorrow. For tonight, just really study these rules, okay? Because you will definitely need to know them. All right, have a good night.